Suppose if y is equal to f of x is one curve and y is equal to g of x is another curve, the area between these two curves between the ordinates x is equal to a and x is equal to b is given by the area is equal to integral a to b. So just find out the area of one part this OAB and multiply by 2. So therefore the required area is equal to 2 times area of OAB. See here, what are the points we got? So when x is equal to 1, y is equal to minus 2. This is 1 point, 1 comma minus 2. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding the areas related to some simple curves. So that is one of the application of integral calculus. Now, so we are going to discuss regarding area bounded by the curves and the lines, some simple curves and the lines. Now, what are the formulas we are going to use to find the area of a curve whenever it is bounded on the x-axis and the y-axis? Now, suppose area enclosed by the simple curves, let us consider a function f of x. Suppose if f of x is a continuous function, continuous non-negative function in the interval, in the closed interval a comma b, then the area of the region bounded by the curve y is equal to f of x and the x-axis and the ordinates x is equal to a and x is equal to b is given by integral a to b f of x dx, or that is also equal to integral a to b y dx. So, therefore, area bounded by the curve on x-axis between the limits a to b, that is the ordinates a to b, is given by is equal to integral a to b y dx. This is very important formula. So, the area bounded by the curve on the x-axis is integral a to b y dx. Now, how the curves looks like? The curve will be like this. So, here this is the curve, this is a curve, y is equal to f of x is a curve, this is the curve y is equal to f of x, and bounded by the curve on the x-axis, the ordinates are, these are the ordinates, x is equal to a and x is equal to b, this is x is equal to a and x is equal to b. X is equal to b, right. So, then the area of this shaded portion is calculated using the formula integral a to b, area is equal to integral a to b y dx. So, this will give the area of the curve, okay. Similarly, if the curve lies on y-axis, that means the area of the region bounded by the curve x is equal to g of y and the axis, that is y-axis, and the abscissa y is equal to c and y is equal to d is given by integral c to d g of y dy or integral c to d x dy. So, therefore, the area bounded by the curve on y-axis is given by integral c to d x dy, c to d x dy. So, here these are the ordinates, y is equal to c and y is equal to d for the curve x is equal to g of y. So, therefore, the area of this is given by the required area is equal to integral c to d x dy will give the area of the curve which is on the y-axis. Now, similarly, suppose if area between the two curves, suppose if f of x and g of x are both continuous in the closed interval a comma b and 0 less than or equal to g of x less than or equal to f of x, that means g of x lies between 0 and f of x for all x belongs to a comma b closed interval, then the area of the region between the curves is given by, between the graphs y is equal to f of x and y is equal to g of x, and the ordinates a to b is given by integral x is equal to a, x is equal to b are the ordinates, integral a to b f of x minus g of x into dx. So, here suppose if y is equal to f of x is one curve and y is equal to g of x is another curve, the area between these two curves between the ordinates x is equal to a and x is equal to b is given by the area is equal to integral a to b f of x minus g of x. So, f of x minus g of x dx between the limits a to b gives the area of this shaded portion. That's it, okay. This is how we are going to find the area of a curve whenever it bounded on the x-axis, y-axis, and if it is in between two curves, y is equal to f of x and y is equal to g of x. Okay. Similarly, the area of the region between the graphs y is equal to f of x and x is equal to g of y, and the abscissa y is equal to c and y is equal to d is given by, so integral c to d f of y minus g of y dy. So first one is f of x minus g of x into dx. Here f of y minus g of y into dy. This is the area. So the area of this shaded portion is given by integral c to d f of y minus g of y will give the area of the shaded portion. Okay. Now by knowing this, let us move on to the problems. Let us move on to a first problem. So you may expect this type of question for 2 marks. Find the area bounded by the curve y is equal to x square, x-axis, and the lines x is equal to 1 and x is equal to 3. See here, what is given? Y is equal to x square. Y is equal to x square. So here the ordinates are a is equal to 1 and b is equal to 3, and it lies on the x-axis. So therefore the curve, what is the curve? Y is equal to x square. Area bounded by the curve, area is equal to integral a to b y dx. Now what is y here? Y is equal to x square into dx, and what are the ordinates? A is equal to 1 and 3. Integrate it. So this is equal to integral of x square is x cube by 3 between the limits 1 to 3. So this is equal to 1 over 3 out, 3 cube minus 1 cube. 1 over 3 into 3 cube, 3 3s are 9, 3s are 27 minus 1. 1 over 3 into 27 minus 1 is 26. So this is equal to 26 by 3 square units. So the required area is equal to 26 by 3 square units. So what is the area? Area is equal to 26 by 3 square units. Now move on to the next problem. Find the area bounded by the curve x is equal to 2y square and y-axis, and the abscissa y is equal to 2 and y is equal to 4. Now first it is, the axis is y-axis, and therefore the area is equal to integral c to d x dy, right. So what is c? C is equal to 2 and d is equal to 4. So therefore the required area is equal to integral 2 to 4, x is nothing but 2y square into dy. I integrate it. So 2 out, integral 2 to 4 y square dy. 2 into integral of y square is y cube by 3 between limits 2 to 4. So you can take 3 out, 2 by 3 out. So 4 to the power of 3 minus 2 to the power of 3. Upper limit minus lower limit, 2 by 3 into, so you can take 3 out, 2 by 3 out, apply the upper limit is 4, 4 cube minus 2 cube. What is 4 cube? 4 4s are 16, 16 4s are 64, minus 2 cube, 2 2s are 4, 4 2s are 8. Subtract these two. That's equal to 64 minus 8 into 2 by 3. 64 minus 8 is 56. 2 by 3 into 56. What is this equal to? Divide it. If it is possible to divide it, otherwise multiply it. 56 into 2 is 112. 112 divided by 3 square units. That's all. So the required area is 112 divided by 3 square units. That's it. Hope you followed. Okay. Now move on to the next problem. Find the area bounded by the parabola y square is equal to 16x and its lattice rectum. What is given here? Y square is equal to 16x. Now y square is equal to 16x is nothing but an equation of a parabola in the standard form, that is y square is equal to 4ax, the parabola of opening right side. This is the curve given, right. So here this is the lattice rectum. Now comparing with y square is equal to 4ax, 4a is equal to 16, therefore a is equal to 16 by 4, that's equal to 4. So what are the ends of lattice rectum? So this is a comma 2a, another one is a comma, yes, a comma minus 2a, L and L dash. So a comma 2a means when a is equal to 4 and 2 into 4 is 8. This is 4 comma 8, another one is 4 comma minus 8. Okay. Now what is to find the area of this shaded region? So to find the area of this complete shaded region, observe carefully. So here x is equal to 0 and another value x is equal to 4. These are the ordinates. Now therefore the required area is equal to 2 times the area of OA. Let us represent this as B and this is C. OAB. OAB. Right. So there are two parts. So just find out the area of one part, this OAB, and multiply by 2. So therefore the required area is equal to 2 times area of OAB. So this is equal to 2 times the ordinate 0 to 4. A is equal to 0, B is equal to 4, and since it is on x-axis, y square is equal to 16x means what is y from this? Y is equal to square root of 16x. Square root of 4 is 16 is 4 root x. So this can be written as 4 root x into dx. Now 4 into 2 is 8. Integral 0 to 4 x to the power of 1 by 2 dx. Now integrate it. Integration of x raised to half is half plus 1 is 3 by 2. X to the power of 3 by 2 divided by 3 by 2 between limits 0 to 4. So just this is taken to the numerator 2 by 3 into, apply the limit, upper limit 4 to the power of 3 by 2 minus 0. Now just multiply this. 8 2 is 16 divided by 3 into 4 can be written as 2 square. 2 square whole raised to 3 by 2 minus 0. 2 gets cancelled. 16 by 3 into 2 cube. 2 cube. 2 2s are 4. 4 2s are 8. So 16 into 3 divided by 8 will give the answer. That's it. So 16 into 8 is 128. So this is equal to 128 by 3 square units. So therefore the required area for this curve is, the required area is equal to 128 divided by 3 square units is the required area. Okay. Now hope you followed. Now on to the next problem. Find the area bounded by the parabola y square is equal to 4x and the line x minus y is equal to 0. Right. Here a parabola and line is given. Now what is given? Y square is equal to 4x and x minus y is equal to 0 means therefore y is equal to x. So the curve will be like this. X axis, y axis, origin. Y square is equal to 4x is a parabola opening right side and the line y is equal to x, y is equal to x, this is a line. So what is required to find the area of this portion? Now just find out the point of contact. What is this? Now here, so just find out this point. Okay. Now solving these two, solving equation 1 and 2, put y is equal to x here, this becomes x square is equal to 4x or x square minus 4x is equal to 0. You can take x common factor, x minus 4 is equal to 0. So x is equal to 0 or x is equal to 4. So the points are x is equal to 0 and x is equal to 4. Here this is x is equal to 4. This is 0 and therefore the points are 4 comma 4. Right. Now listen to me. Just solving these two equations, solving y square is equal to 4x and x is equal to y, substitute the value of y is equal to x in this equation. Y square is nothing but x square is equal to 4x, x square minus 4x is equal to 0. You can take x common factor, x into x minus 4 is equal to 0. So therefore x is equal to 0 and x is equal to 4. So when x is equal to 0, y is also equal to 0. When x is equal to 4, y is equal to 4 for the 16 square of 16 is 4. So therefore the points are 4 comma 4. So here now just find out how to find the area. The area between these two curves is given by, therefore the required area is equal to integral 0 to 4. So what is the area for this? Integral a to b f of x minus g of x dx. That's it. Now therefore this is f of x, square root of 4x. So root 4x minus x between the limit 0 to 4. That's it. Now this is equal to, so integral 0 to 4, square root of 4 is 2, root x is nothing but x to the power of 1 by 2 minus x. Now integrate it. So 2 times x raised to half plus 1 is 3 by 2 divided by 3 by 2 minus integral of x is x square by 2 between the limit 0 to 4. So this can be written as 2 2s are 4, 4 by 3 x to the power of 3 by 2 minus x square by 2 between limit 0 to 4. Integrate it. Just substitute the value of upper and lower limit, you will get the answer. That's it. Okay. Now what is this equal to? Now if you apply the upper limit, this is equal to 4 by 3 into 4 to the power of 3 by 2, 4 to the power of 3 by 2 minus 4 square, 4 4s are 16 by 2, 16 by 2 minus lower limit 0 into a number is 0. So this is 4 by 3 into 4 can be written as 2 square whole to the power of 3 by 2 minus 8. This 2 and 2 gets cancelled. 4 by 3 into 2 cube. 2 2s are 4, 4 2s are 8 minus 8. Take LCM, 3 is the LCM, 32 minus 24. So 32 minus 24 divided by 3. What is this equal to? 8 by 3 square units. So this is equal to 8 by 3. 8 by 3 square units. So therefore the required area is 8 by 3 square units. Hope you followed. Okay, very simple. Now move on to the similar type problem. Find the area bounded by the parabola y square is equal to 4x and the line y is equal to 2x minus 4. Now similar type problem. So what is given? Find the area bounded by the parabola y square is equal to 4x and the line. Same type problem. This is x axis, y axis. Y square is equal to 4x means you have a parabola opening right side. Now what is the line given? So what is given? Y square is equal to 4x and y is equal to 2x minus 4. Solving these two equations, what is x from this? X is equal to y square by 4. Substitute here. So from y is equal to 2x minus 4, y is equal to 2 into x is nothing but y square divided by 4 minus 4. So 2 2s gets cancelled, cross multiply it. So what happens? Y is equal to y square by 2 minus 4. Simplify this. If you multiply by 2, what you will get? 2y is equal to y square minus 8. So y square minus 8 minus 2y is equal to 0. Y square minus 2y minus 8 is equal to 0, a quadratic equation. Factorize this. If you factorize, what happens? So this can be written as 4 into 2, this is y into y, minus and plus, minus into plus minus 4 2 is 8, minus 4 plus 2 is minus. So the factors are y minus 4 into y plus 2 is equal to 0. So y is equal to plus 4 and y is equal to minus 2. So when y is equal to, just take, when y is equal to 4, what about x? X is equal to y square. Y square is 4 square divided by 4, 16 by 4 means 4. So when y is equal to 4, x is also 4. So the point is, one point is 4 comma 4. When y is equal to minus 2, x is equal to y square, that is y square minus 2 square is 4 divided by 4, that is equal to plus 1. So one point is 4 comma 4, another point is when x is equal to 1, y is minus 2. So these are the 2 points. So when x is, this is 0, right? When x is equal to 1, y is equal to minus 2. When x is equal to 1, y is equal to minus 2. And the curve will be like this. See here, what are the points we got? So when x is equal to 1, y is equal to minus 2. This is one point, 1 comma minus 2. Another point is when x is 4, y is 4. So that means what is required to find is the area of this shaded portion. This is to be determined. That's it. Okay. Now what is the required area? So therefore the required area is equal to, I'll write here. So therefore the required area is equal to integral minus 2 to 4. What is x from this? From this, y plus 4 divided by 2 is equal to x. So, y plus 4 divided by 2 minus, what is x from this? X is equal to y square by 4. Y square by 4 into dy. Now here 1 by 2 out. Integral of 1 by 2 out. Integration of y is y square by 2 plus 4y minus 1 by 4 out. Integral of y square is y cube by 3 between the limits minus 2 to 4. Now simplify this. What happens if you apply the limits? So this is 1 by 2 into y square, 4 square 16 divided by 2 plus 4 4s are 16 minus 1 by 4 into 4 cube, 4 16 4s are 64 divided by 3. This is upper limit minus lower limit of into minus 2 square is 4 divided by 2 minus 4 2s are 8 minus 1 by 4 into y cube, 2 2s are 4, 4 2s are 8 minus 8 divided by 3. Simplify this. On simplifying, what we are going to get? So, if you simplify this, you are going to get it as 15 minus, this is 15 minus 16 by 3 minus 2 by 3. Take LCM and simplify. 3 is the LCM. So, 15 into 3, 45 minus 16 minus 2, that is equal to 27 by 9. 27 by 3, that's equal to 9 square units. So, the required area is equal to 9 square units. So, the answer is 9 square units is the area. That's it. Hope you followed. Right. Now, so this is how we are going to find the area depending upon the given condition. So, hope you followed all these type of problems. That's all regarding today's session. Let us meet with different concept in the next session. Thank you. Thank you very much.